It's 4th of June 2026. The time now is 5:26 p.m. Today I'll be explicitly trying to define evolution or AI system of evolution um, using my framework. What do I mean? So here's this repository here. I will continue from there. I'll be presenting some documents where we left off. Primarily, I'll be logging to. I'm logged in now. Let's show my work, my prowess. So we're gonna look at the paper for evolution. Evolution, yes, here it is. So this is a OBNXS cognitive filter flash cognitive evolution. Okay, so filter flash cost transversal function. Today I'll be expressing. I'm trying to develop a language artifact, a linkable then executable file format via uh, executable then file format that can be imported into a language. You have the Python pickle model, which is an object representation of a Python structure. Python pickling is a serialization of a Python object uh, that can be imported from that can be loaded into other systems. So it's a pickle. It's a pickle format. The pickle format is a it's a serialization document. It's a Python object of Python objects in Python object form. You know, of Python representing Python objects in each language of what Python objects are. The problem with pickle is that it is not good for. It cannot be interpreted as from Python, and it's not language agnostic. And the problem I'm expressing is my AI system must evolve and adapt. So let's define this primarily. I define evolution as for a system to evolve, it must address problems in its originally defined domain and solve problems in uh, non-explicitly defined related domains. For example, if you have a Python, a Python, if you have an AI built for one task, it must identify problems within another task. This is problems to identify to solve the overall problem, which are related to other, which can be mapped to other domains of the same problem, other classification of the same problem. For example, if I build an AI system that a robotic system, oh sorry, my eyes, that primary goal is to lift boxes and aid in assembly, uh, aid in assembly line, and move boxes, load boxes onto a truck, load boxes onto a truck. It's infeasible to keep and the AI does the job, but the AI has to encounter certain scenarios. So most of the different problems in the system of I don't intend boxes, if the AI is in assembly, it must not harm the human in rules of robotics, but you must be able to identify problems in the domain, in the domain and instructions working on. The AI must able to attain the know-how by breaking problems into sub-problems and mapping it as runtime uh, into the problems of do's and don'ts to ensure its efficiency without any re-optimization, without any prior optimization. The goal of the system is to develop a file format, such as a Python pickle (PKL) format uh, that is native to Python, but for developing a file format uh, that's link executable, then linkable. I mean, linkable first, then executable. But for our artificial intelligence models, via the filter flash heuristic, filter flash heuristic, filter flash pattern. I will show you the paper now. I'll have a read of it. So here we have the paper on screen. This is ontological Bayesian infrastructure for the OBI, ontological Bayesian intelligence, AI, associated with filter flash cognitive evolution. Evolution is defined uh, as I defined it prior, but mathematically it is not uh, persistent with the framework of the architecture. So by defining this file format, we can take every an enumerable state of a game, of a pawn game, of an AI that can perform of a robotic system that acts out that performs in the world, in the real world around it. But the AI system will have a dedicated file format, so it can be. Let me think of a file format name. Uh, 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 Not AI, not a double issue trader. AI. Uh, 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 Let me think of file format name. No, so if you have dot pickle for serialization, the first step is to build out the file format via the metadata. So the metadata can be the meta. So we call the file dot flash, the flash file or dot ff. Okay, I've decided. So if I decide on the extension .ff .filter flash, um, the filter flash file or flash filter file, uh, 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 or FFI flash filter index. Let me define this properly. So we have the framework here because the goal is to ensure that a model, an AI system that's trained on data is enumerating all the states and loaded into this file format, which is a memory dump of the, like, uh, memory dump of the state. Like like you have an API state of data, and you have like a API dump. You have a filter flash, no memory dump, a whole dump of the states. But the NSIGII files can really do this. What am I saying? So I think the best bet is to extend the NSIGII files, N for number, S for Sarah, I for Indigo, G for gold, D for gold, I for India. I for India. So N for November, S for Sarah, I for India, G for gold, I for India, I for India, which is linkable, then executable file format that is traceable, auditable, and is really it's a polyglottic file format, can be opened by any system if you know how to consume it. Based on specification, V7 specification. The filter flash file format, the NSIGII file format already has this wallet in it. So the goal is a formalization of how the system will put AI, to flash a model or save a model via a simulation of abstract syntax tree. So my problem. So to address this problem, I will prefer to do this way. So we have a parser of a target language, like Python or Node, but it doesn't operate at this state. You have the parser, and then you have the abstract syntax tree of the parser, and then you have the bytecode. So this would be a bytecode implementation of the NSIGII file format that is linkable, then executable. By linkable first, you can import it. Because it's linkable, you can import it. You can import it, and by importing this file format, you are the bytecode is a CISC instruction set, complex instruction set bytecode that ensures uniform normalization, normal character sets, uniform Unicode character sets using normalization. Unicode UC UNUCNS. So what much should you do? So the EST is the abstract syntax tree. I'm trying to more formally. Okay, let me write it down properly. The way I'm gonna actually solve the problem. Let me try to decompose the problem. Decompose the problems. The problem. The NSIGII files is a linkable, then executable file format. It can be imported by any native foreign function interface. However, it is just a file format. It's a constitutional file format. The constitutional file format that needs to be extended. Needs to be uh, uh, extended to support uh wait it's okay, it doesn't need to be standard. Okay, so the problem is that a problem I'm having is I'm trying to use obi elf, the elf linking system, without explicitly making it an elf linking system, but it's gonna be a bytecode, so it's gonna be NSIGII bytecode transformer. Bytecode. So you got the AST, which is abstraction history of a grammar, and the AST are roots of statements, expression, and intent. So the statements are true or false. The expression is the actual object, and intent is execution, is a CISC or RISC instruction execution order. The bytecode can be what to WhatsApp. I'm just prototyping, by the way, and how it relates to the philosophy of the model. So here is the paper I have here. Can I see it here? Yes, this is the paper here I have here. OBIA filter flask evolution. So the first step is to implement define the metadata of the file of the NSIGII file for the bytecode. So the bytecode are executable instruction set, a CISC CISC or RISC instruction sets, instruction set uh, um, of of are CISC instruction sets. So they are CISC. Because it's ref, I'm thinking of rich stage 1, 2, 3, 4. So you are now including like a six instruction set. And by CISC, I mean complex CISC instruction. Yeah. Complex instruction set computing uses large complex multi-low level operations with a single instruction. Complex instruction set. So this is a complex instruction possible. One instruction equals n new instructions versus risks, which are multiple incursion over a feedback loop. Next, I don't know. So this is a program counter, a program memory, a UPC, and a cycle. The SIS approach to minimize instruction path per program over the cycle or per instruction. So the goal is to have a bytecode representation of NSIGII. So the system will execute once it's loaded. Once it's loaded, so you have something that's loaded. So basically, the next steps are to actually from AI. So this is not a problem anymore for me. The problem is now to develop the NSIGII file format via V07, but develop an interface agnostic file format for bytecode for at 5 levels. Level 1, well, that's with 5 targets. The Lexa, the parser, the AST, the bytecode, and the programs, and the program, which is ref stages. Okay, so by creating the AST, which is termed the statement, the the information of the statement of our target languages, the interpretation of a statement over target languages for all interpreters. We can have a statement for Python that's equivalent to node or Lua, expression and intent of a language. And by having a statement, expression, and intent for the AST, we can create a bytecode that is complex instruction set computing pipelining. I don't know what pipelining is. Instruction level parallelism. Mm, okay. Okay. So where do I go from here? So 4th of June 2026. The time now is 5:47 p.m. So the goal now is to remove the AI from the system and just develop NSIGII file format for stages, for various stages, based on the use case. So we're gonna have AST and bytecode. So the bytecode is a scribble file format for an AI system. So you can create an AI system from this bytecode. So I have to research linkable then executable, which is my work. Linkable then executable. OBI ELF, the executable linkable file format I made. NSIGII stage 3 or pipeline in 3. NSIGII stage 3, which is AST and bytecode, and that is it. Thank you for watching this video.